So I am Alana Tuckey, and I am the stats lead faculty here at Jackson Community College, so I'm in charge of probability and statistics. And I am married to the other stats faculty here, who is the guy that's in charge of this whole thing, along with her husband in the back there. See now, this guy. So hi, Heather. How you doing? Anyway, and Allison has lovingly agreed to help me out with this, even though she's not a stat specialist. She's an algebra specialist. So she works a lot with the algebra courses and with the calculus courses, which I teach as well. But she's not as into stats and probability because she's saner than me. Okay. So and I'm just going to be honest with you guys right now. I'm not a gambler. So I'm a probability person.
Because you're a statistician.
Exactly. As a matter of fact, you learn in statistics, and you guys are going to learn today why you don't gamble. Why when you walk into a casino, you go, that's nice. You get the free food and the free drinks, and you kind of walk through and stare at the people who look like zombies in front of the slot machines, and you walk out, and you go, I have my money now, and I'm going to go see a movie, because, all right. So that's what we're going to teach you, but we're going to teach it to you mathematically, all right? So that, I got to go over here. Maybe I should make you in charge of spinning.
I'll be in charge.
All right, so I'm not going to remember what I put in here. Okay, so first thing, I love that my photos being taken all the time. It's just great. My hair was wet because I don't dry it. All right, I get a little curly.
It's too early.
Yeah. Okay, so, all right, so what is the probability? Does anybody know what probability is? Yeah, go ahead, Alex.
The likelihood that something will happen.
Exactly. So before I roll, and I'm going to roll this sucker because
it's big.
It's quite large and it could really hurt somebody.
You could roll this one.
Oh yeah, okay. Before I roll this die, it's kind of nice, six-sided. Right, before I roll it, you don't know what it's going to be, right? And then you say, okay, what are the chances of rolling a 5? Hi, honey. My husband's waiting at me in the hall. So what are the chances I'm going to roll a 5? 1 out of 6, right? You know it without me rolling it. Oh, that's totally good.
You should go.
So what are the chances of me? It was totally right. No, what are my chances of my rolling it? Well, it's all about before I do it, right? Once I've done it, why am I so excited? Because I totally did it, right? So what are the chances that I roll a 5 now? 100%, because it's done, right? So probability is about what's going to happen in the future, right? But once you do it, well, you either got a 5 or you didn't, right? So it's talking about, it's the way that we're going to measure whether something's likely to happen, right? So, everybody good? That making sense? Now, how low can a probability get? 0, right? Okay, so I'm going to roll this 6-sided die. What's something that could not happen? 7, exactly. So the chances of me rolling a 7, big fat 0, right? Or what's as high as I can get? Oh, by the way, you should be filling this out, right? I gave it to you, right? So the lowest you can, I got blanks in there for a reason, people. All right, so it can be as low as 0. Will not happen. The Lions winning the Super Bowl ever. Big fat 0. Oh, come on. Seriously, past experience has taught us that the Lions ain't going to win the Super Bowl, okay? I don't even think they're going to get to the Super Bowl. I got to be honest. Okay, so probability is something that will not happen. 0, okay? What's the highest a probability could ever be? Exactly, 100%. He's like, I should have introduced Jerome, by the way. Jerome is another math professor here at Jackson Community College, so don't mind if he starts sneaking in answers. But he doesn't teach, well, he does teach a little bit of probability, so no cheating. Cheaters never prosper, okay? All right, so the highest you can ever be is 1. Everybody filling that in the blanks? All right, so will happen for sure. Ooh, that's a hard one. So what's something that will for sure happen?
You roll between 1 and 6.
I will roll something between 1 and 6, right? That's for sure going to happen. There, that's 100%. Or, I don't know, that the sun is, or that the sun will rise tomorrow. Not quite 100%, right? But really, 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 really close, right? The probability that, wow, thinking of something really, the Yankees will get to the World Series at some point again. It's gonna happen. Got a lot of money in the Yankees, okay? So that will for sure happen, therefore it's 100%. Is that making sense to everybody? All good? All right, so then the higher the degree of probability, the more likely it is to happen. So if the highest you can get is 1, 100%. The lowest you can get is 0. Everything else is in between. So like when and I hate to pick on sports, but when a basketball player, Kobe Bryant, gets on And he's like, I just give 110% every time, blah, blah, blah. Can you give 110%?
No.
No, right? So with the words that come out of his mouth, just proves that he doesn't understand probability and therefore will be a very good gambling partner for you. Because you will totally clean house with this guy because he doesn't understand that you can't get above 100%. It is physically impossible. The most you could ever get is 100%. Coolness? Everybody good? All right, moving on. And we'll get to the gambling, I know. Hold that thought. All right, so what are odds? So odds are not the same thing as probability. So when I say probability, what I'm talking about is the chances that something's going to happen. Odds are very much related to that, but odds get used in gambling more often. They're a quicker way to determine payoffs. So when you place a bet of a chip, which I forgot to call it chips. When you place a bet of a chip, how much you get back from the bank if you win depends on what the odds are. So it's just a quicker way to say it. It doesn't do a lot of people a lot of good in gambling casinos and lotteries to say, well, your chances of winning that are 1 in 6. That's not as useful as your payoff is something, right? And so they'll tell you what your payoff is, and that's what odds are used for, right? So there are two kinds of odds. There's odds in favor. Those are actually the true odds. When statisticians, probability people, nerds like me, are talking about odds, I'm usually talking about odds in favor. So, and then that's the number of times it will happen against the number of times it won't. And then there's odds against, which is the ones that are actually used in gambling. They're called payout odds, right? So, and I think on the next slide I have an example. So I can, yeah, I do, so let's go with it. So suppose you're talking about this big guy. And you're going to say, okay, I want to toss a 5, like we did before. It's like I knew it was coming. All right, so I want to toss a 5. So I want to know what are the odds, right? We all know the probability. Probability is 1 in 6. But I want to know the odds of rolling a 5, right? Okay, so let's start with the first one, which is you write it as a ratio. So this, and we're going to start with the probability, and we're going to work our way down to odds. So the probability would be, as if you write it as a ratio, 1, because there's 1 5-sided side, in how many? 6, right? Because there's 6 total. So you write the words literally 1 in 6. That's a ratio, 1 in 6. Right? All right, what's the next one? You guys can see it on your slide.
Fraction.
Fraction. Okay, so if you're going to write that as a fraction, how would you write it? Go ahead. 1 6. You write 1 and then like a slash and then a 6, right? So that's 1 6. Cool. All right. Now, anybody got their phones? You can do a little decimal action. What is 1/6 in a decimal? That's percentage. Dude, I had them out of order. I know. Hold that thought. He's right. Right? I know. I'm sorry, but I got the slide out of order. So do the decimal first, right, and then come back and do the percentage. The decimal will be 0.16 with a little bar on his head. He goes on forever. I should have brought good markers with me. 0.16. Ooh, that's a terrible marker, but he's got a little bar because it's 6, 6, 6, 6, 6, 6, 6, 6, 6, repeating forever and ever and ever and ever. Groovy? Everybody's good? Okay, then the percentage, you said earlier, 16.67%, right? Everybody good? 16.67. I'm sorry, I can write for you. Oh, you're so good. See, I knew I needed Allison. She helps me. All right, so 16, and I gotta be honest, Allison was totally like, we're gonna put the table here and that there. She's like all about organizing this room around. All right, so 16.67, does everybody get where the 7 came from? The rounding, right? Because if it goes 6, 6, 6, 6 forever, then the next 6 will round that last 6 up to a 7. Sorry, a little algebra, pre-algebra review there, a little math review. Okay, everybody all right? Nobody freaking out? Okay, so then what are the odds in favor? Now, odds are not 1 in 6, I'll give you that. All right, so the odds in favor of rolling a 5. 1 to 5, right? Now, we write that a lot of ways. So you can write literally the words 1, 2, 5, right? 1, T-O, 5. Or you could say 1:5, that's a common one. In gambling, it's 1-5 a lot, right? So they'll do like a 1, and then they'll do a little dash exactly like that. Right? All of them work. Everybody good? So that's the odds in favor. What's the odds against? Yeah, Alex?
5 to 1.
5 to 1, right? So 5-1 or 5:1. Again, the most common one you'll see in gambling is 5-1. That's the way they tend to write it. Right? And of all of these, that's the one that gambling uses the most. They're all correct. Everything you wrote on that page is totally correct. But the one the casinos will use is the last one, 5-1. Lottery tickets, for some strange reason, do this. And they write the word in instead of to, which is actually not correct. So feel free to complain to the Michigan Lottery Commission. I do it all the time, but it's not correct. So they actually write it wrong. If you look at the backs of like scratch-off tickets, not that anybody under the age of 18 can buy scratch-off tickets, but all of you get your parent to buy $1 scratch-off ticket, you can look at the back and it'll say it incorrectly, right? It'll say the odds is 1 in this, which is not true. That's probability. Probability is 1 in 6, right? So they're doing it wrong. And drives me nuts. I want to drive to Lansing and have them fix one little word and they won't do it. All right, so everybody good about odds? Everybody kind of have a sense of what odds are? Does it make sense? Yes, we're good? Okay, well you're already doing better than the government in Lansing, so congratulations. All right, so now let's look at the roulette table, and I made you guys a color copy of it so you can kind of look at it. Obviously it's up here, and if you come to the casino later you can play on the big table, right? But I thought it would be good for you guys to have it right there in front of you. We all good? Okay. All right, so on the roulette table you have a wheel right here, and you have a table where you place your bets, right? And I've given you in this picture, so I'm stealing yours totally, apologies. All right, so I've given you a picture of the wheel, and then a picture kind of the table where you place the bets. And this is an American roulette table. Roulette is not actually from, thank you. Roulette is not actually from America. Roulette is actually a French game. It was invented around the 1700s. It was originally thought of in the 1600s, but it was invented in the 1700s, and it's been very, 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 very popular. Roulette is one of the most popular casino games in Europe. That's why you see James Bond always playing it when he walks in the casino, right? So he walks by and all the fashionable people are playing roulette, right? That's why. It's extremely common in Europe. It is not every casino has a roulette table, but it's not a very common game to bet on in America, and you're gonna see why. Everybody good? Cool. All right, so, sorry, I hope I'm not losing anybody. All right, so we got this very complicated table, and it's like, wait, what? There's all this stuff, and there's a wheel, and all this. So I thought we could take a moment and kind of analyze it just a little bit. All right, so what do I have next? Oh, questions. Big one. Does the wheel, and I knew I'd get one. I'm now warm. See, guys, now I'll see my awesome t-shirt. Yes, thank you. See, 5 out of 4 people have a problem with writing. Get it? 5 out of 4 people have a problem with writing odds correctly. All right, so is a number due? So as you play, you're like, okay, come on, number 5, I keep betting on you. You should show up at some point, and you will eventually. But does the wheel remember what it's rolled? No. Right? So if the ball is sitting right now in, that's number 6, black number 6. So if it's sitting in black number 6, does that mean, oh, it's totally ready for it again? Like black number 6, it could happen or it could not happen. It's no more or less likely than any other time. Right? And this is the fallacy that a lot of people fall into when they play lottery tickets. And you're like, okay, I'm going to keep scratching. Something's going to win. You're right. Something will win eventually. But it's not going to be enough to compensate for all the times you spent playing, right? So that's what I'm trying to get you to see. In the long run, you're not better off with this. Okay, but it's fun. But what happens is the wheel has no memory. It doesn't remember what it rolled before. It just keeps rolling, right? It's called independent. It means that and it happens with dice too. When I roll a die, right? Oh, I rolled a 5 again, right? I could roll it again, and it might team 5, and it might not. It doesn't remember what I rolled. It's not like, okay, 6 is gonna happen any time now. It doesn't do that. Yeah, go ahead, Alice.
That must be rigged.
No.
Getting 5.
It's not. 6.
Oh.
It's not. I will tell you that this die is a little bit weighted, and I can talk to you about why that is, because if you look at it, so is this. Do you see how you gouge out the holes for this? Okay. Casino dice don't do that. They don't gouge out the holes. We have some over there. They're flat, smooth. And the reason being because when you gouge out holes like this, what are you doing?
Making it lighter.
Making this side lighter and making this side the heaviest side. So in a die like this, what's going to roll most often? Heavy stuff goes to the bottom, right? And so 6 is going to roll the most often. The lightest side is going to be up facing most often. And that's why in casinos, they don't do dice that are gouged out like this, right? They do dice that are flat and smooth, right? No, they just have the dots painted on, right? They're actually not even painted because even that would weigh the dice a little bit. They're actually built into the machine itself. If you ever watch Ocean's 11, one of the things is that they infiltrate like a dice making machine, and so they get it to do stuff that they shouldn't do. It totally would never happen. All right, but anyway, I mean, I like George Clooney and all that, but it's not going to work that way. But that's okay. But if you look, they'll show you how they make dice, and it's really special, and they're really careful with it because you can't have the die be loaded at any point. And even then, a lot of times the dealers will take dice off the table. They won't let you roll with the same dice all the time. So they'll let you roll, and then they'll take those dice, and then they'll let you roll with a different set, and so on. In craps, they usually have about 10 dice sitting there, and you choose 2, right, all the time from it. So, cool? All good? All right, so, next. Games that are dependent, games that it affects, what you do the first time affects what's left. No dice games are like that. But card games are, right? So if I'm dealing from you a deck of cards, and I give you a king, then you guys don't get a king because she's got it. Or she has the king of spades, and you're not getting the king of spades, right? And it affects what's happening. Those are much harder to figure out than dice games, right? Because dice games, you just kind of roll, or the spinner, the wheel. It's independent every time, so that's easier. That's why the room is full of independent games, in case you didn't notice, and not dependent games. Poker, stuff like that, Texas Hold'em, those are all much more difficult because everything that gets dealt out affects everything that's left, and it makes the whole game much trickier. You all good? All right, so then everybody always wants to know, so I'll tell you. Are the numbers randomly placed? So if you look at the wheel on your little thingy, and you start up at the top, I can't do it. If you start up at the top, and do you guys see the white double O? Do you kind of see that? And then do you see the 2 red ones next to it? There's a 1 and there's a 36. Do you see that? What do they add up to? 37. Okay, so now look at the 2 black ones near that. 13 and 24. What do they add up to?
37.
Oh, look. And then 3 and 34. What do they add up to? 37. And then 15 and 22. 37. And the next one, 34 and 5 makes, or no, what is it? 5 and 32 makes 37, and so on. They don't always make 37. They do make 39 and 38 in a couple spots, but it's almost all 37s around the board. Yeah?
And I also noticed like 1 and 2 are on opposite sides.
Yes. Absolutely. So it's like 1 is on one side, 2 is on the exact opposite, right? And then did you notice how on the wheel it alternates color? It goes red, black, red, black, red, black, red, black, red, black, right? Around. And then the 0 and the double zeros, anybody know what colors those are?
Green.
Green. They're considered green, right? If you look at the wheel, which you can get up and look at later, they're actually green, right? So, everybody good? All right, so, and then, just a little side note, what do all the numbers add up to? Everybody wants to know. 666. Oh. I'll let the parents think about that for a second, right? So they add up to 666, just in case anybody was wondering, right? So I'll let you ponder that and what that means. All right, so we're good? Now I added in something, this is not on your handout. I added in something because I wanted you to be able to see. So if you just look at the roulette wheel, I thought, or the roulette table picture, I thought this is kind of confusing. Like, how do you figure out what to bet? Like, where do you place chips and how does that work? So if you look at your thing, you can think about where you're going to put chips. So I'll show you my stack right here. So when you have a stack of chips, you play them on different places. Right? And so when you look at yours, like I could lay a stack of chips on, and I think the first one I did, the 6 numbers is not supposed to be out there, but that's right, red and black. Right? You guys see the red splotch and the black splotch? See that? They're right here on the board, you can't see it, but there's red right there. So if I put my chips on red, I'm betting on red. If I put my chips on black, I'm betting on black. We all good? Okay.
Are you only allowed to put them on one color?
No, you could put them on both. That would be a very bad idea though.
Right.
but you could, because what's going to happen is one of them probably is going to win. Of course, you could lose it all, because if the green ones show up, then you're really in trouble, right? If 0 or double 0 comes up. But what's going to happen is you spend 8 chips, you lose 4 of them just to gain 4 back. It ends up being worthless to you, all right? It's a wash, right? So it doesn't. So you can put chips all over the place. It's actually not a good idea. The more chips you put down, the more you're going to be losing, right? Just a little side note for you. Right? We're going to learn why in a little bit, hopefully, if we got time. All right. So then, evens and odds. So you guys see, it's kind of small, and it says even right next to the red splotch. Do you see where it says even? So you could put your chips, and there's a little marker for it here. You can put your chips on even. You can put your chips on odd, right? Even numbers, odd numbers, just like what you think, right? And then what else we got? 1 to 18, which are the low numbers. And then 19 to 36 is over here. And those are the high numbers. And again, those also have even shots, right? There's 18 slots of that out of 38. Yeah, go ahead.
Quick question, with the 0 and double 0, do they count those as even?
No, they do not.
They do not.
Nope. Even though mathematically they are even. And I know, yes. See, the algebra teachers can remember, like, wait a second, 0 is even. I agree. And I thought the same thing, but you know, I'm not going to go against the gangsters that, you know, run this game. I'm just going to kind of go with what they, no, honestly, the French people that invented it, they don't count. 0 is its own special thing. So no, it does not count as even. If it did, then everybody would bet even all the time because it would be by far the best bet on the table. Yeah. All right, so then dozen. So if you can look here, it says the first 12 right there. It says first 12, second 12. Do you see it? Third 12. So the first 12 is those first 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? If you put it, it's right here. If you put it there, then you're betting on all those numbers, right? And there's 12 of them. And then the next one, second 12, is the middle 12 numbers and so on. All good? All right, and then column. Down at the bottom, at the very bottom where it says 2 to 1, it's kind of hard to see, but it says 2 to 1 down there at the very edge. Do you see it? Right there? That if you put the chips there, you're betting on that entire column of numbers, right? So all 12 of them. It's the same probability of winning as a 12, as a first 12 or second 12, because there's 12 numbers in a column, right? Because there's 36 numbers total. Yeah, go ahead, Alex.
Do those 2 zeros count?
No, they do not. They are special, right? They don't count for anything. The 2 zeros are what totally mess up the game for the players, right? The fact that they're not counting in, it doesn't seem like much because it's only 2 numbers, but it totally ruins your gambling, right? All right, so then there's the columns. What's next? Oh, by the way, those are called outside bets because they're outside the numbers table. So if you look at like the rectangle where all the numbers are, those are inside bets, right? So you're betting in with the numbers. And the outside rim are outside bets because you're betting outside the number portion of the table. All good? All right, inside bets are any number bets that are inside when you're playing chips all over the place. So 6 numbers, you can do that a whole bunch of ways. I gotta think about that. So 6 numbers, there's 5 numbers, right? So 6 numbers, what you do is you play your chips on a corner. I can't even describe it. Like, do you guys see where 33 and 36 are against each other? Do you see that? If you put your chips right on the corner between 33 and 36, it's understood you mean that whole double column, right? You mean both those lines. You mean 33, all of them, 33, 32, 31, 36, 35, 34, you mean that whole thing. So if you put your chips right on that corner in between the two, that's what you mean. And then there's a 5-number bet, which is that same thing on the corner, but up here between the 0. So you see where the 3 and the 00 meet? Do you see that line? So if I put my chips right there where the 3 and the 00 meet, or in this case the 1 and the 00 on this table, that would mean I'm betting on the 5 numbers. 0, 00, 1, 2, 3. Those 5 numbers. And then what else we got? 4 number, which is a corner. So if you put your numbers, like where, do you guys see 1, 2, 4, and 5? Is that where they are? 1, 2, 4, and 5. See that? If you put your chips right on the corner between 1, 2, 4, and 5, right in the middle, that means you're betting on all 4 of those numbers. Okay? And then there's a 3-number bet, which is a line. So that's if you put your chips over on the edge.
But not in the corner.
But not in a corner. So like if you take them over to where the 3 is and kind of lay them in the middle, that means you're betting on 3, 2, and 1 all at the same time. And then 2 numbers is split. So if you put your numbers right, you're stacked right in between 1 and 2, like where 1 and 2 are, you put your numbers, you're stacked right on the line in between the two of them, you're betting on both 1 and 2. With me? And then single number is the easiest. You just put your chips right on a number. I bet on 1. There we go. right? So that's really easy to figure out. The inside bets are actually a little bit harder to figure out, like, where the heck am I laying my chips, and like, what do they mean? And I'm not a professional dealer, like I said, so we're gonna have to be very patient with me when we run this game later on. All right, so those are your outside bets and your inside bets. Are we all good? Okay. So then, assume you're going to place a $1 bet on red. Which is right here. So I'm going to put my chips on red. And I'm only going to do one chip. $1. All right, one chip. All our chips are worth $1. All right, so the payout amount is listed. Now, I gave you guys a table that had payout amounts. Do you guys see it somewhere? It says, what are the odds? Hey, Rob. Oh my gosh, we have a whole
Got a whole crew here.
Okay, so does everybody see the table? What does it say the payout is for red? 1. Okay, so the payout amount, write that down, is listed as 1. Okay, and then let me pick the next thing. The payout odds then would be what? So the payout is 1, the odds are 1-1. Right? 1 to 1. Everybody with me? Everybody good? So the payout is 1, so the payout odds are 1 to 1. If you lose, then what happens? What are your winnings? If I lose, I guess something happens. Well, actually, I'm the banker, so nothing happens to me because they're my chips. But if Jerome is playing and Jerome loses, Jerome bets on red, okay? Lucky red. So if he bets on red and he loses, what are his winnings? 0. He didn't win a thing, right? I'm the banker. I take his chip and I put it in my little case over here, and you don't get it, right? His winnings are 0. If he loses, his winnings are 0, right? What's his profit then?
0.
Negative.
Minus. It's negative. Because profit can go positive or negative. He won 0, so his profit is -1. Very important, right? Everybody good? Now, Jerome, I'm not going to make you a loser anymore. If Jerome wins, yay. All right, if he wins, what does he get back and what is his profit? So if he wins, what does he take back to his little space? Go ahead, Alex.
His winnings are 1 and his profit is 0.
If it better not be profit 0, otherwise we wouldn't gamble. You're on the right track, though. It's positive, both of them. What does he take back to his table? He gets 2 chips because it pays 1 to 1, right? So he gets his chip back. There's the one he gets back, and then he gets 1 from me. There's the 1 to 1. Get it? He bet a chip, and he gets a chip. 1 to 1. So he ends up with 2 chips. So his winnings are 2.
I quit.
All right, that's very smart. Very smart. His winnings are 2, but what's his profit? 1, because he spent a chip to play, right? So he wins 2 chips, but he only gets a profit of 1 chip. Thank you. I appreciate that. Give my chips back. All right. All right, everybody good? All right, so we're going to make a table of our profits and our probabilities. Okay. So, profit. If he wins, his profit is what? +1, right? So you put +1 right there under the profit. And if he loses, his profit is -1 because he lost, right? I mean, there aren't any business professors in the house or anything, but when you have a profit that's negative, that means you've lost, right?
Correct.
Thank you, Ron. I love when the business professors back me up on things. Okay. All right, so +1, -1. Now, this is going to be a little confusing. You have to look at your roulette thing. What are the chances of lovely Jerome winning this bet?
Just on red, right?
He puts it on red. What are the chances?
About 50%.
No, we need to know it exactly. So look at your wheel and count.
On the table, it's easy to count on the table.
I think it's easier to count the table.
So there's what? There's 3 colors, is that right?
That's right.
Okay.
You know, late students don't get to ask what.
Sorry, I was just rough.
That's
Just
okay.
tell me to be
No,
quiet.
that's okay. So look at your table and count how many red spaces there are. And I even did it in color for you because I'm not kind. There's 18, right? Now, how many spaces total are there?
38.
Close. 38 because of
Zero.
those 2 darn zeros that keep messing up your life, right? So the 0 and the double 0. So it's not 50%. If the zeros weren't there, it would be 50%. It's the zeros that are that totally muck up your life, all right? So you got 0 and you got double 0, so it's 18 out of 38. Thank you so much, Allison. Which I have no idea. You guys have phones, right? You can find what 18 out of 38 is in a decimal. Phone calculators? Nobody? Come on. All right.
I know.
See? I knew the math teacher would have one. All right. See, she's on fire. 0.47. Right? Okay, then what if you lose? What are the chances of you losing if you bet on red? It'd be, well, we can do it. What would the fraction be? How many spaces are not red on this sucker? 20, right? So it's 20 out of 38. All good? Everybody okay?
What's the percentage?
Yeah, I have no idea what the percentage is. 52 points. What'd she say?
So 53.
Roughly.
Right, from rounding to 1%.
All right. So then, how do we find the expected profit to the player? That's really important to us. So there's a formula for it. I know, again, business wouldn't know anything about expectation, right?
Yeah.
All right. So you take your,
Yeah.
it's called expected value. That's exactly what it is. So you take your losing profit times the chances that you're going to lose, plus your winning profit times the chances you're going to win, which you guys just figured out. So you take this times that, plus this times that. Calculators in the house? No. Unfortunately for you. Anybody got one? I've got a calculator. Come here. Who feels comfortable with a calculator? I feel like these two guys in the back corner really, they feel like they need a calculator. You guys sure you might? No, I need quiet people in here. Come on. Oh, passing it off. Kyle, man, you're killing me. Come on, multiply. 1 times 18 out of 38 plus negative 1 times 20 out of 38. Here's a hint. It's not positive. Should be negative, right? Anybody find it? Negative. Well, I know you found it, Mr. Math Teacher. What'd you get?
Well, I did that.
Okay, what'd you get?
0.06 negative.
Negative 0.05. Actually, it's 526. Good.
Oh, okay.
Yeah.
She brought it to the whole number.
It's because you used the rounding
Yes,
percentage.
Negative.
Negative 0.0526. It's all right. I didn't make you use the calculator. And bonds. Did you guys get it? Negative 0.0526. That's your expected profit. So wait a second. That means that for every bet you play, like if I play 1 chip down, what should I expect out of this? I should expect to lose, right? Every dollar chip you play down, you expect to lose how much? 5 cents. 5 and some change. So you expect to lose 5 cents per chip. Okay? Or 5, well, we'll get into it a little bit. Okay, so let's flip to the next one. What if you bet 2,000 times in a row then? Or what if I lay down 2,000 chips, which I don't have 2,000 chips, so nobody gets to bet that high. But if I lay down a huge stack of 2,000 chips, how much would I expect to lose? Well, okay, so you take your 5 cents per chip, right? And you multiply it by 2,000, what'd you get? 100 and, do it. It's 10, if you take 0.0526, let's be accurate about this. 0.0526, you multiply it by 2,000.
105.2.
105.2, you expect to lose $105.20.
Place them all in one though. You would expect to lose it all.
Doesn't matter if you bet on one. Okay, so no, actually, just hold that thought. So, and I was doing the tall column, but honestly, it's the same thing, and that's what I wanted you to see. I actually did these out of order. The big tall column is this one, right? When you place 2,000 chips at one time, that's this guy. And of course, in casinos, do they really let you lay chips? No, what they do is give you bigger chips, right? Like this color's worth 1,000, or whatever. I've never seen a $1,000 chip, but if I had, okay. So the other, it's exactly the same that if I play one time, then play again, and play again, and I always play on red no matter what. It's the same thing, right? Both of these are negative $105.20. It doesn't matter if you put it all at one time, or if you keep playing one chip, one chip, one chip. Which one's gonna last longer? This one, right? So you'll be at the table longer. It'll feel more fun to you, right? Doing this. but it's no different than doing it all at once, just shooting the whole thing. Right? Mathematically speaking, you're gonna lose $105, more or less. Now, does that mean everybody loses really $105.20? Can you actually lose 20 cents on a roulette table? No, right? But what's gonna happen is you're gonna win, lose, win, right? And it averages out to $105. And that's why Jerome is very smart. You see what he did? He was like, I'm up one chip, I'm gone, right? You get up one chip and you leave, right? Once you're up, you're gone, right? So, and of course, does that mean you will always get up? Can you, will you get up if you sit there long enough? Well, no. I mean, there's no guarantee because the roulette wheel has no memory. Remember, it's independent. It doesn't know that you're down or you're up. It doesn't care about you. It's got its own spinning thing to do, right? So it doesn't necessarily have to go up for you. Right? You can sit there for an hour and never get up. It happens. Real good? Okay. So then, what's next?
House edge.
Oh, house edge. So, the expected profit to the player, we all said was negative 0.0526, right? Write it down, negative, it's like I planned. So negative 0.0526. So what's the expected profit for the house? I'm the banker. If you're losing 5 cents, what am I gaining? 5 cents, right? So it's positive point, no, it's positive, it's an edge. So it's not a 100%, it's just the 5% extra that we care about. It's like interest, right? So you'd say 0.0526, but it's positive to that one's negative. So if this is negative 0.0526, then the next one's positive 0.0526. So we agree? Good. Now, the thing is, most people, when they play, they don't play one chip. Unless you're me. I play one chip at a time. And actually, I've only gambled twice, so that's not going to count. Right? But you play one chip. But they often write this as a percentage, not as that. Now, why? Well, because if you're betting $300, it's 5% of that $300, right? So it's 5 cents for each chip, and so we write that 5.26%. Does that make any sense? We can't write on the screen. They'll let us. We don't have a smart board. We're not that cool. Okay? All right, so it would be 5.26% here as a positive percentage. Are we good? Okay? Okay, so to catch that, red, which is the nicest bet on the table. There's several of them that are that good. The nicest bet on the table, you're still losing on. And you're losing about 5% of everything you bet. Okay? And I don't know if you know this, but 5% for adults in the house, 5% on an interest rate for a bank account would be lovely. Am I right? Right? 5% is quite high. It might not seem like it, but it totally is, right? 5% is quite high if you keep playing over and over and over, right? Okay, so then, what are the rest of the house edges? Let's do a single number. So if you were going to do a single number, like 1, I'm going to bet on 1. Okay, so how are you going to figure out the house edge? So you are losing times that we have, I think I wrote the formula for you guys somewhere. It's on the second page, so I can totally steal your thing. All right, so it's right here. So expected profit of the player is the losing profit times the probability of losing plus the winning profit times the probability of winning. So if I bet on the single number, what's my losing profit? If I lose my chip, what's my profit? -1, right? So it's -1 times, well, let's do the winning. Let's do that's okay. What's the winning profit for a single number? You have to flip back, sorry, you have to flip back. Look at the table. No, flip back. It's quite high. Flip back the page. There you go. Look at the payout. Look for the payout. 35. If that number wins, I get 35 chips back. Woo-hoo! Actually, 36. I get my chip back and 35 more. That's how payout works, right? So I get my chip and then the bank gives me 35 more. Nice, right? So my profit's 35. Woo-hoo! Right? But unfortunately, what are the chances of me doing this, right? So what are the chances of that number 1 coming up? 1 out of 38. I have no idea what that is in a decimal. Right, 1 out of 38, and then losing 37 out of 38. Every other slot on that wheel will give you a loser for me. Okay? So can you guys just bear with me? To do this, what you do is you multiply this times this plus this times this. Would you be okay if I just tell you what it is?
Yeah.
It's negative 0.0526. It's exactly the same. Interesting. As a matter of fact, I think I have one at the bottom of that slide, Allison. You're so wonderful. All right, click on that, would you? And then I actually have that table you guys have sitting here. Do you see what's happening? It actually doesn't matter, except for one place, what you bet on. On a roulette wheel, the house edge is 5% for everything except the first 5. See that? That's not a mistake. That is a sucker bet, right? You would not want to bet on that. First 5, it means you put your chips right here, where the 0, the 1, 2, 3 meet at the top. The house edge on that bet is 7.89. Nobody, if they know what they're doing, would ever place their chips there, right? Of course, my personal opinion is that you don't know what you're placing your chips inside that thing unless you've done a class like this anyway, but the casinos are hoping you have no clue what you're doing. All right, so if you place your chips on the front, on the first 5, you have a 7.89 loss, which means you're gonna lose almost 8 cents for every dollar you bet. Not good at all. No, no, no. All good? Everybody okay? Do you guys feel like you have a sense of what house edge is? Yes?
So they're making 2 chips every time.
Well, they're making 7 cents off of every one of your chip. So if you think of your chip as a piece of pie, 7% of it gets lost, right? But of course, you can't carve out of the chip. What it means is in the long run, it averages out to 7%. So 7.8% actually.
Of every bet.
Of every bet, right? So if you bet 1,000 times, you would expect to lose $78, right? So if you bet 1,000 times. All right, so then I thought, let's look at 2 dice for a second. I thought, roulette, let's look at dice. So is everybody cool? And I gave you guys this picture. Is everybody cool with this picture? Make sense? Oh, sorry, what time are we done?
9:50.
Oh, God. Man. Well, I want to teach you guys about hedging. Hold on.
So we'll skip the dice.
Skip. No, okay. So, okay. Flip back. So go to the next one real quick. Can you guys just trust me? Just flip to the next one. There's a cage. If you roll 2 dice and you want to place your bet on a 7, I'll go into it later. The house edge is 16%. Just trust me on this. I can prove it to you later. The house edge is 16%. It's really high. It's one of the cages that's in the back, right? It's 2 dice. You have a choice of rolling. You have a bet on 2 through 6, 7, or 8 through 12, right? You're adding the 2 dice, like a Monopoly. So you have this, and then your house edge is 16%. I can prove it to you later. And so people are like, well, that stinks. Why don't I just bet on everything? If I put a chip down on 2 through 6, so you got 2 through 6 in here, you got 7 right here, 7's worth more, and then you got 8 through 12 here, because 2 dice, right? The lowest you can get is 1 and 1, highest you can get is 6 and 6, right? So people are like, well, that stinks. If I put my chip here, I've got a 16% loss. Ugh, right? If I put my chip here, I've got a 16% loss. Ugh. So it's not that much. Why don't I just put 3 chips down? 1 chip, 2 chips, 3 chips, then I'll be guaranteed to win. Right? Seems logical. It's called hedging. And it's what you were talking about in the back. You're like, well, why don't you just play your chips down on a lot of things on the roulette table? It's a very bad idea. Right? So here's what's going to happen. If you do this, what's going to happen if you play down, and actually, can you click on that real quick? I think I've got it calculated. Crossing my fingers, hoping. Actually, click on over and under right there. You're awesome. All right, see it right here? What if you bet on all 3? Do you guys see what the house edge becomes?
Wow.
Ouch is right. So if you bet on each one of these individually, it's 16%. That's what I calculated at the top. If you bet on all 3, what's happening is you're paying 3 chips to play every time you play. Right? And roulette is the same thing. The more chips you put down in the more spots, the worse it is for you. It's called hedging your bets. You're trying to ensure that you win by playing more chips. But of course, what does that mean? It means you're losing more all the time. You're bleeding chips, right, all the time, right? You're better off with single chip bets, right, kind of continuously going and hoping that you can end up positive like Jerome did in the long run and walk out, right? But when you go to the roulette table, you watch people just put chips all over the place, and then you're watching one slip, it's all gone, right? All gone. And sometimes they'll win one of those bets. You see also the same thing with people that go, you ever seen people buy lottery tickets? And they'll just buy like, oh, I want 1 of this, 3 of that, 2 of that, and they'll just sit there forever in the gas station buying all these scratch tickets, right? What they're trying to do is they're trying to hedge. They're trying to buy enough tickets that they'll be guaranteed to win. But the problem is, and I actually did this once, I went and bought 1 of everything just for the fun of it, because I wanted the probabilities on the back, so I'll be honest, right? But I did it. I spent $40. Guess how much I won? $10. No, I won 10, because you're gonna win, right? But I didn't win enough to compensate for all the losing I did, right? That's hedging, right? You're trying to ensure you feel that win, that scratch, oh, I won. You're trying to get that emotional hook, but it's not enough to compensate for all the chips you're laying down to do it, right? So I'm trying to think if there's anything else major I want to tell you. Oh, I know, the last bit. If we go to the very, very last, not very last, the second thing. So the moral of the story I wanted to teach you guys is that the house always wins. Always, right? Great song by OK Go called The House Always Wins, but it's totally true. Or in quote, Catching Fire, the odds are never in your favor, okay? They're just not, right? So and adults will know this more than kids, but what do casinos do to keep you there?
They do free things.
They give you free stuff.
Free alcohol.
Have you ever walked into a casino? I walked into one as a kid. I mean, I didn't do anything, but I walked by one because they're in hotels now, right? Any windows?
No.
No windows at all. They want you to have no sense of daylight, no sense of time passing, right? The windows, there are literally no windows in the whole place, right? So no windows, no clocks anywhere. You will not find a clock on a wall anywhere in a casino. They give you free drinks, free pop, free booze, free whatever. Anything that will make you make worse choices. They allow you to smoke. Because if you just sit there and smoke cigarettes and play slots, you'll sit there for longer if they let you smoke, right?
Can't go outside.
Sorry, what? Yeah, you can in casinos. Casinos were the #1 complainer about that law. They were the ones who were like, no, you have to let us have smoking. They want you to have smoking because if you have to go outside, then you'll stop gambling for a minute and go, maybe I should drive home. And right? So casinos lobbied very hard to not have it so you can still smoke in casinos. And they give you free drinks. And what's more, now parents, they used to do coins, right? You used to put your coins in the slot and feel it. Do you ever have a place where you can put coins in anymore? It's like a card. It says, this is this guy. They have a swipe card. They know exactly how much money he's won and lost, and it's tied to his credit card or his debit card. And when he's lost enough, they know that, hey, if he loses like 20 times in a row, that he's going to get up and leave. So about time 18 or 19, they come over and offer him free dinner, offer him a show, offer him whatever it takes to keep him in the casino longer. They totally do it. The casino business will tell you. I've got many documentaries where they tell you that's exactly what they do. If you start losing enough, they will do whatever it takes to keep you there. Because the longer you keep playing, the more you're going to be losing. Because the house edge will win out in the long run. Cool. And if you want to see the house edge totally kick your patukas, come to us this afternoon. We're going to actually play these games, and we will kick your. It's just not even funny. Allison's really competitive. She's over on Beat the Dealer just whipping all of us. It's just not even funny anymore, you know.
So I wasn't doing too bad.
Yeah. Yeah, you lost all your chips twice, okay? And Alex, I want to talk to you. Alex lost the chips 4 times, okay? So
I did like 5 before.
Yeah, he kept going to get more stacks, and it didn't matter. He just lost them. Lost them.
Yeah, they were trying to teach me not to bet all the
chips at the same time.
But it just went through one ear and out the other.
He lost his stack a few times. Let's just put it that way. Anyway, so everybody good? Do you have any questions? Feel free to stay after, and I think you have to go to your next session.
Yes.
At 10 o'clock. I should have done a 2-hour thing. Then we could have actually played.
That was good.